Hello, in this video, we're going to go over the questions that you had for your Unit 3 test from the unit Frogs, Fleas, Painted Cubes. So the question says, these four tables display various patterns of change. So the key word here is that we're looking for patterns of change. So let's zoom in and let's check to see what patterns do we notice in our tables. So I noticed that for my X values, they're all increasing by 1. So I can just go ahead and show at least like how that's working out with 3 here. There we go. Now let's look to see what's going on with our Y values. So from 2 to 4, I can say that there's an increase of 2. And then from 4 to 6, I also notice that it's increasing by 2. Same thing with 6 to 8, increasing by 2. So again, when we notice that there's a constant rate of change here because it's increasing by a number every single time, we know that this kind of table is linear. Okay, now let's look at table 2. So if I zoom in all the way to table 2, I notice that my X values are increasing by 1. Same thing here, plus 1, plus 1. All right, now let's focus on our Y values. So for our Y values from 1 to 4, we will have to add 3. And then from 4 to 9, we will have to add 5. And then from 9 to 6, we will have to add 7. Now I noticed that this is definitely not linear because it doesn't have a constant rate of change, meaning it's not adding or subtracting by the same number, so a constant number. So because I have been taught in this unit that these are called the first differences, let me go ahead and write this here. Back in again. So these are the first difference. Now I have to look for what I know as the second difference, because that was another thing that we learned as well. So I'm going to do it a different color. See if I can make it thinner. There we go. So from 3 to 2, I have to add 2. And then from 5 to 2, I will have to add 2. And just because I want to be sure, because this was the first difference right here. Let me check one more time here. From 16 to 25, I know that you will have to add 9. Now let me check this was the first difference. Let me check the second difference now. So from 7 to 9, I will have to add 2. Well, this shows me that the second difference right here that I just circled is constant. And in this unit, we learned that when the second difference is constant, we have a quadratic function. So I'll just label this one quadratic. Now let's look at table 3. So for table 3, we're going to do the same thing again. We're going to look to see what is going on here. And we're going to look for the patterns of change. And same thing with table 4. I will not do these two because those you should be able to do on your own since you have to do those test corrections. The next thing that you have to do as well is identify which of these tables shows a quadratic relationship. The key word again here is tables. So yes, we identify one of them, but there's another one here that is also quadratic. All right, now let's go to question 2. So for question 2, it says the expression negative 4.9 t squared plus 50t plus 2 represents the height in meters of a toy rocket t seconds after its launch. The initial height of the rocket in meters is, all right, so anytime that they give you an equation, we did tell you that it should be important for you to go ahead and graph it. So I am going to my graphing calculator and I'm copying down this one, negative 4.9 I think you can change it to X or you can keep it as C, but I'll put X since that's the variable that we always use. Squared plus 50x plus 2. All right, there we go. So this is what it looks like. Sometimes you guys tell me that it looks like a straight line. Remember, you need to zoom out. And when you zoom out, you start seeing that it is a parabola. It's a little bit skinny, but you are able to see that it definitely is a quadratic function. And we see the parabola. Now, the question is the initial height of the rocket. So this keyword right here, initial height. When we talk about initial height, we're talking about the starting value. So if we can do it two ways, we can look at the graph and see what was the initial height by looking to see it's telling you right here, the y-intercept is your initial height, your starting value. So at 0 seconds, the rocket is at a height of 2. And I believe that this is in meters. Yes, in meters. So it is 2 meters high. That's how you know which one is the initial height. It's telling you the initial value, y-intercept, and all of these are synonyms, meaning they're the same thing. So I'm just going to write this real quick. So starting value, initial height, initial value, they all refer to the same thing. They're all referring to the y-intercept, but not just the whole y-intercept, but you have to be mindful. They're only talking about the 2. So this value here, your y, is the one that they're talking about in this case. So your initial height is 2 meters. We know that's in meters because it was telling you before in the question that the height was being measured in meters. All right, so for that one, you should be able to see it. I also did want to show you that there's another way that you can also get it. You can also go ahead and look it up in the table of values. We can leave it the same way it is at this point. So if you see your table of values right here, we see that it's because we know that this is in seconds. So the X represents seconds, and we know that your Y value represents meters. So we know that at 0 seconds, the height of the rocket was 2 meters. So that's another way for you to get that answer. All right, let's look at the next question. So for this next one, it says a ball is thrown into the air from the top of a building. Okay. The height ht of the ball above the ground t seconds after it is thrown can be modeled by, so they give me an equation here. How many seconds after being thrown will the ball hit the ground? Okay, so I am a visual learner, so I would definitely like copy and paste it just to see what it looks like. So I'm gonna go back. And just get my equation there, 16x squared plus 64x. All right. Okay. So right away, I am seeing that there's an issue with this question. I think they meant to put a negative 16 here. Yes, this is what it's supposed to look like. And we know that it doesn't look like what was there before, because if you look at it, it wouldn't make sense that you throw a ball and it goes down and it comes right back up. Okay, so the way that it had to be, it had to have a negative 16, and then see how it changes the graph. Now your parabola opens downward. So we know that the building's height is the starting value, because that's where the ball is going to start at. So the ball right now, it's at 80, and this is in, it doesn't tell us, but let's assume that it's in meters as well. So the ball will be here, and I'm going to draw like a little quick sketch so you get an idea of what I'm talking about. So let's pretend the building is here. I'm going to make a quick sketch. Forgive me, it's a little messy. This is the building, and then the ball is going to be here at 80. So that's where it's starting. So somebody threw the ball, it went up, it reached the highest value, the maximum value, and then it came back down, because obviously when you throw something up, because of gravity, it's going to have to come back down. So we know that the initial height is 80. Now, be careful, because this question is not asking about the initial height. It's asking you how many seconds after being thrown would the ball hit the ground. So we know that at 0 seconds, we know that the 0 represents the seconds. At 0 seconds, the ball is at 80 meters. At 2 seconds, it is at 144 meters. So when does it hit the ground? So hitting the ground would be the point that is down here, because it comes right back to the ground. So I'm not going to give you that point, because you should be able to graph it and get it, but at least you'll have some understanding of how that equation represents the ball being thrown from a building. All right, let's look at the next one now. So for the next one, we have Fred is given a rectangular piece of paper. If the length, so they're talking about length here, is represented, sorry, if the length of Fred's computations piece of paper is represented by 2x minus 6, so that's the length, and the width, so the width is here, is represented by 3x minus 5, and I did see you guys all did exactly what I would have told you to do, which is go for drawing something. You can draw your rectangle, and that way you're able to represent it. I did see all of you, most of you used the rectangle model. Some of you did use the distributive property. I'm going to show the rectangle model just for this video, but you're also able to just go ahead and distribute here, since you know that length times width gives you your area. And that's really important. So area equals length times whatever your length is, you have to multiply it by your width. So that's that. Now we're gonna go ahead and show how you will have to set this up. So I know that my length is 2x minus 6. So you have 2x, and then you have your negative 6 because it's in minus 6. Then your width, you have 3x, and then minus 5. And then from there, you should be able to fill the insides of this. I'm going to do just the very first one, and then you guys should do the other parts inside. So the first one we will have to do is 3x minus 2x, because to get this first little box here. So I know that 2 times 3 is 6, and I know that x times x is x squared. So you go ahead and find out all of the insides, and then you'll be able to combine like terms so you can get your final answer. Don't forget to write your final answer down here where it says total area, which should be in the expanded form. That was question 4. All right, now let's look at question number 5. It says, which of the quadratic functions below has the smallest minimum value? So remember, we have to find out the minimum value by looking at the minimum point and looking at the y. All right, so let me actually not just say. So minimum value refers to your minimum point. So you have to look at your minimum point. You should be taking notes on this. So your minimum point will always be a coordinate, right? X comma y. But you are only focusing on the values. So you're only focusing on this value. on the y. You're not focusing on the x and the y. So for instance, if we look at number 3 already gives you a table, right? So you have to look for your lowest value, your minimum value. So I'm looking at these numbers and I have to see which one is the smallest one. I can already tell that -6 is the smallest value. You see, -6 is the smallest value. So that's your minimum value. So for number 3, I know that it is -6. Now let's look to see at number 4, because that one is already given to you as well. So I see that my minimum point is down here. I'm gonna have to zoom in because I can't see it myself. So I'm gonna zoom all the way in. And I see that the minimum point in this case is 1, 2. Yeah. So it's 2. I'm sorry, let me so I'm just drawing the coordinate. Parentheses, comma, 2, because that's my x value. And then I gotta figure out my y value. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So the minimum value on this one is -10, because remember, I am only focusing on the y value. So right away, I can tell that if I were to compare the graph and the table, the table has a minimum value of -6 and the graph has a minimum value of -10. Therefore, number 3 cannot be it because it has to be the smallest one. Now for this ones, you have to, they give you equations, right? So when they give you equations, you should know that you are able to put them in the graph and check to see. I'll do the first one, but then you have to do number 2 to figure out your answer. So the first one says x plus 5, x plus 2. Okay. X plus 5 plus 5, and then x plus 2. Okay, there we go. So I click on the lowest point. That's the rule. So we have to zoom in. Don't be like me. You have to zoom all the way in, look for your minimum point. And I see, remember, I don't focus on the x value. I want to focus on the y value. This is my x, and this is my y. So this is my smallest value. So I know that the graph had a minimum value of -10. The other one, the number 4, choice 4, and this one has a -2.5. So I know that this one wins because right now this one seems to be the smallest one. So this one cannot be it either. So now you're left with 2 choices. For your test corrections, you have to graph this one and see if it has a smaller minimum value than this one. Now let's go to question 6. For question 6, and you have multiple questions like this one. The expression 49x squared minus 36 is equivalent to, so there's a keyword here that says equivalent. Equivalent means that it is the same, it's identical. And we know that this one is in expanded form and these are all in factor form. So the first thing that you need to do right away is graph the equation that you're given, 49x squared minus 36. (49x squared plus 36). And I always verify just to make sure. Because that's another thing, like being digital. Oh, see, it's minus 36. So it's very important that you verify that you're actually writing the correct one. All right, so I see this graph right here. It's very skinny, but I see it there. Yeah, here we go. So the next thing that you need to do is grab your answer choices and see which one falls right on top of it. Because if it's identical, it'll be the same one. So let me start with choice 4 actually. I don't know if it's choice 4. But so I just graph choice 4 on the same one. So do not delete the one for the question. Keep it there. So 7x minus 6. And then 7x plus 6. I forgot to put the parentheses. And 7x plus 6. There we go. Oh, you guys got lucky. It's that one. So look to see what happens. So you can take it away. These are actually equivalent. And you know that they're equivalent because they fall right on top of each other. See? So it's actually choice 4 for this one. Just make sure, because we did scramble some of the answer choices. The way that you'll know that it is not the correct answer, it'll be like, let's just graph number 2, just so you can see what is not equivalent. So 7x minus 6 to the power of 2. Look at what happens when they're not equivalent. When they're not equivalent, they don't fall on top of each other. So this one is not equivalent because it does not fall on top of each other. So that one you X out, and this will be your answer. And if you did that for all of them, you'll notice that they will not fall on top of each other. The only one that will fall right on top of this one will be choice 4. Same thing for question 7. You should be able to do it. It's the same thing as question 6 that we did before. And this one, again, this one is like question 5, the function with the smallest minimum value. So look back to see how we did question 5 or question 8, so you can find out the minimum value. And the same thing here for number 9. We did that one with this one with question 4. So question 9 and question 4 are very similar. And question 9 is actually a little bit easier because they drew the rectangle model for you. Question 10 here, it says the height of a ball Doreen tossed into the air can be modeled by the function. So they give you the function where x is the time elapsed in seconds and h of t is the height in meters. So we have seconds is x and the y values are going to be the height in meters. So the number 5 in the function represents, so let's just say you didn't know how to read the equation. If those of you that know how to read the equation know what exactly it means, you're a constant. But those of you that don't, there's another choice. And the way to do it is just go ahead and graph your equation. So you have negative 4.9x, negative 4.9x squared. What else? Plus 6x plus 5. So we have this parabola here, and because we know that the situation is that the height of a ball was thrown. So we know that a ball was thrown, right? And we know that time, again, can only be counted with positive number. We never talk about time with -1, -2. There's no such thing as -1 seconds. So we have to start looking at the graph from here. Starting from here, 0, 1, 2, and so forth. So they're asking you, what does the number 5 represent? Well, we see the number 5 here. Let's see if in the graph, what does it represent? So again, if you looked at the other one where we talk about the building, this one is talking about the starting value. So let's look at our answer choices. The time at which the ball was at its highest point. Is that true? Is this representing where the ball is at the highest point? That's not true. The ball is actually at its highest right here. So let's see, what does that 5 represent? The maximum height the ball attained when thrown in the air. That is not also the maximum height. The maximum height was 6.83. The time at which the ball reaches the ground. Not true, because look, the ball comes right back to the ground. So it hits back, the ground is down here at the x-axis. It hits at 1.79 seconds. So let's look what the 5 represents again. The initial height of the ball. And if you paid attention to what I told you before about the synonyms, that 5 is representing exactly where the ball started at 0 seconds. So it started at 5 meters. Now for this one, you should be able to graph this and get the x-intercepts, your y-intercept, and your line of symmetry. There's no other thing that I can tell you but to graph it, and everything is going to be there. So x plus 2 and x plus 4. And you see right away, we know that this one does not have it has a minimum value. So your minimum value is going to be -3, -1. So just be careful here. It doesn't have, you can just put NA, which means not applicable. And we know that the minimum value is -3, comma, -1. The only thing I wanted to touch is the line of symmetry. The y-intercept is easy to get because it even tells you like the name of it. And your roots are your x-intercepts. So again, your x-intercepts are your roots. The thing that I did want to touch is the line of symmetry. So your line of symmetry has to go through your x-axis. And again, we did talk about this in class, like we will have to cut your parabola here in half. So that means that your x line of symmetry will be represented by x equals, what's your x value? Look at your points, -3. And some of you put +3. I'm not sure why you did that, but maybe you didn't see it well, but it's a -3. All right, let's move on. Question 12. And this one you should be able to graph. So for this one, it's just graphing the equation. So just graph your points there and determine when it reaches the maximum height. So you should know that your when is represented by your time. So look to see when the ball is going to be at the highest point. And then your bonus questions, you guys cannot do them, but you should definitely look to see them just so that you're able to get, you know, just some more experience. But this one is saying not equivalent, okay? Keyword. And this one, you should be able to answer with all of the information that was given to you by the rest of the video. So please look back from the beginning and hope to see your test correction soon.